Okay, so let's find the exact value of something like this, where you have a trig function composed with the inverse trig functions or vice versa. So for something like this, first thing you want to make sure is this is in the domain of this function, and it is, so that means this is valid. It's not undefined. So now we can go ahead and do the following. We're going to let theta to be equal tangent inverse of 12 over 5. So what that means is that tangent of theta, it's going to be 12 over 5. So pretty much we're looking for what is theta. That gives us 12 over 5. But of course, we're not going to use a calculator. We're going to do it by drawing a right triangle. So pretty much what we have done is we can rewrite this as now cosine of some theta, because now this is replacing theta. So first we want to draw the right triangle from the substitution and then figure out cosine of what theta is. So from this, we know that the right triangle will look something like this. Let's call this right angle. Let's suppose theta is here. Now we know tangent by definition is opposite over adjacent. So that means across from theta is the opposite length, and this would be the adjacent. So that means this is going to be 12 and this is going to be 5. So if that's the case, now we just need to figure out what the hypotenuse is. So we're going to use Pythagorean's theorem to figure out what the hypotenuse is. So let's do that on the side. So we have a square plus b square is equal to c square. So again, a, b are the sides. So that will be 12 square plus 5 square equals c square. 12 square, 144. 5 square, that's 25, equals c square. So we know we have 169 is equal to c square. So that will give us c is equal to 13. So the hypotenuse is 13. Well, now we can complete the question. We were initially looking for what is cosine theta. So now cosine theta is adjacent over hypotenuse. So that'll be 5 over 13. So that's how you find exact value of composition of inverse functions and trig functions. Let's go ahead and do another example. So here's another problem. Again, we're going to let this be theta, and always make sure that the input is within the domain of the inverse function. So we know 4 over 5th is within the interval -1 and 1. So this is good. It's not undefined. So now we let theta be equal to sine inverse of 4 over 5. So that would mean that sine of theta is equal to 4 over 5. And again, from here, we can draw the right triangle. So here's our right triangle. And here's theta. And here's the right angle. So sine is defined as opposite over hypotenuse. So that means across from theta is opposite. So this is the opposite length. This is the adjacent. This is the hypotenuse. So our opposite is 4. Our hypotenuse is 5. We're looking for that. Now that's from Pythagorean's theorem. We know that's one of the sides. So we know we have a square plus b squared is equal to c squared. So we're missing one of the side. Let's call it a b. So a could be replaced with 4 squared plus question mark squared is equal to 5 squared, because that's the hypotenuse. And then we get 9, well, sorry, not 9, 16. 4 squared plus question mark squared is equal to 25. Subtract 16 from both sides. So we will have question mark is equal to 9, and then question mark will equal to 3. So we know our missing length happens to be 3. Well, now that the triangle is completed, now we can answer the question. Well, we're looking for secant of sine inverse of 4 over 5. Well, sine inverse of 4 over 5 was theta. So this is really secant theta. Well, secant is the reciprocal of cosine. So we know secant theta is 1 over cosine theta. So what is cosine? Well, cosine is adjacent over hypotenuse. So this would be adjacent, which is 3. So 1 over 3 over hypotenuse 5, which simplifies to 5 over 3. So that will be the exact value of secant theta. Let's do one last example. So for this problem, we want to find cosine sine inverse of x. Now, this is not a real number in there. It's a variable. So but that means the result you're going to get will involve x in there. So let's do the same thing. We let this be theta. So let theta be equal to sine inverse of x. And we know x is between -1 and 1. So now we apply sine on both sides. So this means that sine theta is equal to x. And I'm going to write x over 1 so that we have that fraction line. Now we draw the right triangle. So here's our right triangle. So let's draw a nicer triangle. So here you go. And let's suppose theta is here. So across from it is opposite. So this is opposite and this is hypotenuse because sine is opposite over hypotenuse. And now we need to find this length. Well, that will be the adjacent. So again, using Pythagorean's theorem, we know that a squared plus b squared is equal to c squared. We're missing one of the leg. We know c squared is 1 square. One of the side is x squared. We're missing b squared. To solve for b, we do b squared is equal to 1 minus x squared. And finally, b is equal to a square root of 1 minus x squared. It's going to involve x in there because we don't have an exact value. So that means our missing length is going to be the square root of 1 minus x squared. Okay, so what are we looking for? Well, we're looking for what is cosine of theta is. Well, cosine is adjacent over hypotenuse. So this would be square root of 1 minus x squared over 1, or we can just say this is a square root of 1 minus x squared. So there you have an algebraic expression of this composition. Okay, so I hope this helps.